Hey guys, this is Mrs. Schoenberg. This is lesson 8.2, graphing linear equations in two variables. I hope you have the capability to print this out. Notice there are little graphs on the second page. We're actually going to be graphing almost everything we do today. But let's just jump right in here. We're going to be graphing linear equations by plotting points. We are going to graph linear equations by plotting x and y intercepts. And we're going to study how to graph horizontal and vertical lines. Okay, first off, just a little bit of lingo here. When the book talks about standard form, that is something in the form ax plus by equals c, and there can be no fractions in standard form. I don't know that you'll need to know this for this chapter, but just so you know that. When we talk about the y-intercept, this is simply the point where a line crosses the y-axis. And when we talk about the x-intercept, it's the point where a line crosses the x-axis. So let me demonstrate. This is the x-axis and this is the y-axis. If we have one point that is, let's say, get these on here. Let's say we have one point that is 0, 4. So 0, 1, 2, 3, 4. Point A. And we have point B that is negative 3, 0. Negative 3, 0. Let's say that's point B. Now we could draw a line between these 2 points and we have our line. So this is our y-intercept and point B is the x-intercept, the point at which it crosses the x-axis, and the y-intercept is the point at which the line crosses the y-axis. So just so you know that going into this lesson. So here's how we're going to graph. We're going to locate any 2 points. We're going to make it simple. This step's hard for students. They don't realize that, yes, you get to pick the points. I am not telling you what to pick. You get to pick them. Sometimes you have to be strategic. Sometimes you just have to keep it simple. Then you're going to plot the 2 points on the Cartesian coordinate system. You're going to draw a line. I hope your lines are straighter than mine. You're not going to, if you don't like me doing a not perfectly straight line, I'm going to drive you crazy. And you can check. So here's our first example. Y equals 2x. For every single one of these, this is what helps me get started. I draw my XY table. Then I can pick anything I want, any value I want for X or for Y. In this case, I am going to say, oh gosh, I want X to be 1. Let's see what Y is. So instead of X, I will put in a 1. So when X is 1, Y is 2. And we have our first coordinate, 1, 2. Now we need one more point. What do you want to try this time? I like to keep it simple. What if for X we put in a 0? Let's see what we get for Y. Y equals 2 times 0. Y equals 0. So when we put in a 0 for X, we get a 0 for Y. Now you really only need 2. You can do as many as you want. Let's say just for kicks, we put in a negative 1 for X. So 2 times negative 1. So in this case, Y would be negative 2. So let's go ahead and graph. So scrolling down here, we have our first line was y equals 2x. And the first point that we had was 1, 2, and then we had 0, 0. So if we go over 1, up 2, we had a point there. And if we did a point here through 0, 0, once you have the 2 points, you can draw a line. Now this gets a little interesting in Hawks, but basically once you plot 2 points, Hawks draws the line for you. Now just for kicks, let's see if that third point we came up with lies on that line, and of course it should. -1, -2. Now my line's not straight, but if I went over -1 and down -2, it's very close, okay? It's very close. So it does lie along that line. It's just, I didn't draw my line straight. Okay, let's try another one. 2x plus 3y equals 6. Let's draw our xy table. Now, again, x can be anything. I like to start with 0. So let's just see what happens. If we put in a 0 for the x, what do we get for y? So that cancels. We have 3y equals 6, divide by 3, divide by 3, y equals 2. 2. Now we can put in any value we want, and it doesn't have to be for x, it can be for y. Let's say though we put in a 0 for y. So 2x plus 3, this time we're putting a 0 in for y, and we're going to solve for x. So 2x equals 6, x equals 3. So when y is 0, x is 3. So we have our 2 points. We have 0, 2, and we have 3, 0. By the way, we did happen to find the x and y intercept here. Not on purpose, but I just want you to notice that. So 2x plus 3y equals 6. So this graph is going to be of the line 2x plus 3y equals 6. And we have found values, x and y, that make this true, which means it lies on this line. So the first point we had was x was 0, y was 2. 0, 2. And the second point was 3, 0. Now, if I were to ask you, what is the x-intercept? You would say 3, 0, and the y-intercept is 0, 2. Now again, trying to draw a straight line here. This is the equation of the line, 2x plus 3y equals 6. These 2 points we have found lie on that line. Now, I just want to note that there are an infinite amount of points that lie on this line, and this line goes on in both directions forever and ever. So there are millions of points that satisfy, an infinite amount of points that satisfy this equation, an x and a y value, because this line goes on and on in both directions forever. Okay, coming back. We have graph x minus 2y equals 1. So let's do our xy table. We can choose anything, anything. I kind of would want to try in a 0 for y, because I know when I do that this goes away, this 2 times 0, so I actually have x is equal to 1. Okay, so that was kind of an easy one. Then the next one I want to try, it doesn't really matter. Let's try y equals 2. So I have x minus 2 times 2 equals 1. X minus 4 equals 1. Plus 4, x equals 5. Okay, so now we have an x minus 2y equals 1, and we have our 2 points, 1, 0, and 5, 2. So 1, 0, 1, 2, 3, 4, 5, up 2. I can draw my line, and that was for the graph x minus 2y equals 1. Okay, moving on to the next one here. This lesson, you need to read the instructions as always, but sometimes it says, hey, you got to find the x-intercept and the y-intercept. It's pretty much the same as what we were doing up here, but you have to put a 0 in for the x value, and then the second time through you have to put a 0 in for the y value. I'll show you what I mean. So for letter A, the x plus 3y equals 9. What this is going to look like is, let's do our xy table. And then we have to, first time through, we have to put in a 0 for the x. So substituting in a 0 for the x, I have 3y equals 9, divide by 3, y equals 3. Now, the second time through, I'm going to put in a 0 for the y. So x plus 3 times 0 equals 9, x equals 9. That's really all there is to it. We have our x-intercept and we have our y-intercept. So let's go ahead and graph this. It was 0, 3. That's the y-intercept because that's where it crosses the y-axis. And then we have 9, 0. Guess I have to guess out here. It's somewhere out here. Okay? And that was for the equation of the line x plus 3y equals 9. Okay, let's try one more of those. And this time, it is again finding the x and y intercept. So we have to put a 0 in for x first. So 3x minus 2y equals 12. So negative 2y equals 12. Divide by negative 2. Y equals negative 6. So when x is 0, y is negative 6. And then we're going to put in our 0 for the y value. So 3x minus 2 times 0 equals 12. 3x equals 12. Divide by 3, x equals 4. So if we were to plot those, and I'm not going to, but we would have 2 points. We could draw a line, and we have found the x-intercept and the y-intercept. All right, lastly, but not least, this is where students get really, really, really confused. And I want to make sure I spend enough time on this in this little page that I have. But we need to understand horizontal lines and vertical lines. Horizontal lines go side to side. And they're y-equal lines. Vertical lines, think of vertical jump. They are up and down, and they are x-equal lines. Now, one way I try to help you remember this, if there's a good way to memorize this, is doesn't y kind of look like an upside down H? See, if you kind of looked at it, y looks like an upside down H. And when you look at the x, doesn't there look like there's a lot of V's in there, like V for vertical? That's one way I try to memorize it. You might have a better way. But when you look at the line, when you're graphing y equals 4, first of all, when you do your x and y table, y is going to be 4. It's always going to be 4. X, there's no x up here, right? X can be absolutely anything, okay? Now, if you were to graph this line, and you went 0, 4. Let's say that's 4. 1, 4. 2, 4. You can surely tell that y equals 4 is a horizontal line that goes through 0, 4. Now, let's draw an xy table, and let's look at x equals negative 2. Well, x is negative 2 and always will be. Y can be absolutely any value you want it to be. So when you plot this, negative 2, negative 2, 0, negative 2, 1, negative 2, negative 1. This is a vertical line that goes through x equals negative 2. Now, finally, the chapter will throw something at you that looks like this. Graph 2x equals 10. And students absolutely have no idea how to tackle this. First of all, I want you to get the x by itself. So divide by 2. Now we have graph x equals 5. Now you tell me x equals 5. Is that a horizontal line or a vertical line? I hope you said vertical. So once we do our xy table, X is always 5. Y can be absolutely anything. So this is the graph of x equals 5. And it was 5, 0 and 5, 1. 5, 0, 5, 1. And as you can see, this is a horizontal line, or excuse me, it's a vertical line through x equals 5. And you can just see all these millions of points that lie along this line. These are all the y values. That's why y can be anything. X will always be 5, but y can be anything. And lastly, let's say Hawks gave you a problem like this. 3y equals 12, and they want you to graph it. If I divide both sides by 3, I have y equals 4. Y is an upside down H, standing for horizontal. This is going to be a horizontal line through y equals 4. I can prove that y is always 4. X can be anything. So 0, 4. 1, 4. So on and so forth. So now that I have my 2 points, I can draw it and I have it. I'm going to end this lesson here.